Okay, so we've gone through everything that I would consider the physical layer, in the sense that I've been trying to convince you that it is possible to send signals over the internet. Obviously, you know that because you interact with it every day, but I really do find that it helps a lot to be able to understand how that might actually happen. Otherwise, it feels like magic. It just feels like things are happening and they just do, right? But we know a lot of things now. So to move forward, right, to really get to the good part of this, which is gonna be related to software more than the physical way that a message is sent, we're gonna blast on up in the tree of knowledge, and we're gonna probably start moving down to connect it back to what we've already learned. And we're gonna skip ahead and we're gonna talk about browsers. So why browsers? We're going to talk about browsers because browsers have a very, very special place in how the internet works. So let's get over here. We're going to start with a recap, okay? So, recap. What do we already know? What have we already convinced ourselves of? Well, we've convinced ourselves that binary data can be sent through physical signals, like through light waves in fiber optic cables, through electricity, and over radio waves, right? Electromagnetic waves. So we know that binary can travel. Traveling binary. Good. We also know that in order, we also know that there is an infrastructure in place, right? There is a infrastructure that took a lot of work, took a lot of resources to put in place, that allows us to all connect together via these three mediums, basically, of sending binary. And so we know that the ISPs are our gateway to that infrastructure. We know that there are fiber optic cables that run under the ocean. And we also know that there is a way that has been sorted out within this huge infrastructure that allows us to say we want a message to go from point A to point B. And that's with addressing. And that's all well and good, but you can have all of this in place, and it's still not clear how this relates to the internet today. There's so much going on. There's so much of your life that is based on using websites, using web apps, and going on the internet. So what we really need to understand is what websites are. And the only way you can understand what a website is by understanding what a browser is. Because I think that a lot of people, they probably think that the website came before the browser, but it can't really work that way. And the reason for that is that the browser, like if we take a browser like Chrome and we just think about it, a browser is just an application, right? In the same way that when you double click like a video game that you enjoy, right? There we are. It's like this guy's shooting something. When you double click a video game that you like, what happens is that video game pops on the screen. It might go full screen. It might be in a little window on your computer. But you go into that game and that game has a purpose. It takes your inputs and it moves a guy around on the screen. A browser is exactly the same in the sense that it is an application. When you double click on Chrome, there's nothing like special about it really. It's just another application, but it has a different purpose. And the purpose of a browser, right? Like the thing that a browser needs to do when you really want to break it down, just put a little website in there, is one, it gives you a way to send web requests. Lets you send a web request, which just means sending a message using an address to another computer asking for some data back. Two, it understands It understands how to interpret, how to use, I should just say, how to use standard data format, standard data that comes back, right? And the key word here is standard. And what I mean by standard is just that we've agreed on it beforehand. So I think the best way to kind of go through this is to think about like what a browser started off as. So I just looked it up before this video, and the first browser came out in 1990. Can't remember its name. I think it was called, it had a weird name, I can't remember. But all it could really do is receive data back, probably in the form of HTML, which I'll get to later, and display text on a screen. So you had the screen, you had text and stuff like that. Now, it was able to show images, but it couldn't show images in line with text. At least that's what the thing said. So in this 1990s browser, right, basically what you would do is you would say, I want to go to website.com, right? A computer would receive that message via the mediums that we talked about before, and then it would send back some HTML, and then the browser would show you all of the text and then give you links on the side so that you could click them and load and download the pictures to see them, right? And HTML, its purpose is simply to say what content is there. And you might have seen HTML before. It looks a bit like this. HTML, like that, and then you'll say something like H1, the title, right? Something like that. That's got a slash, P, etc. You write some writing in there, and then you do this. So this is kind of what HTML looks like. I'm only putting this there so that you can identify it, so that if you've seen it before, you kind of know what I'm talking about. And what this is, what this is just a way to describe content. It doesn't tell you where the content goes. Well, it tells you, I guess, where the content goes in the sense that it tells you the order that the content comes in, i.e. like H1 comes first and then P comes second. But it doesn't say anything about like, oh, I want H1 over to the right, or I want it in the center of the screen, or anything like that. It's literally just like a list of stuff. And at the beginning, that's all you needed. That's all people really, really wanted. But as time went on and people started using the internet, they started wanting more control, right? And so as time went on, and I'm not completely sure when this happened, maybe it was part of the original HTML stuff, to be honest, there came along something called CSS. And CSS is kind of like HTML in the sense that it's another specific kind of file that you can give to a browser. But instead of saying what content is in a page, it says how to style that content. So it's a way to choose fonts. It's a way to choose colors. It's a way to say that something goes to the left or to the right. And you might have seen this before also, because some people used MySpace or anything like that. You might have to write your own CSS. So CSS kind of looks like this. You go P color, something like that. And you go like red. Maybe. Can't completely remember, but it kind of looks like that. You got like the curly brace and stuff. What this would do is if you gave this to a browser that was more modern than your old 1990s, let's say Netscape 1, an old browser that became eventually became Firefox and stuff, Netscape 1, what that would do is it would mean that, okay, let's say I had also given it the HTML from before, it would put down the title and the paragraph, so the H1 and the P tabs that were in the HTML. It would put them down onto the screen, but it would also make all of the P ones red, right? And so now you're starting to describe what things look like. And then what people thought was they were like, okay, you know what? The thing that is running a browser is a computer. So I don't just want to be able to describe the content that I have at a website. I don't want to just describe the layout of that content, the colors of that content. I want to be able to run code, because if I can run code, that means, one, I can animate things. I can make it like fireworks, and I can make colors change in the background, and I can scroll them because I can send a programming language now. I can do calculations. I could potentially make tools. I could make calculators where people go to a website, they put in a number, they say, what's 2 plus 3? And press submit, and then it calculates it for them because it's a programming language. But also, it means you can hack people. So what came along was a language called JavaScript. And JavaScript is just a programming language. Could have been anything really, but it just happens to be JavaScript. And JavaScript kind of looks a bit like this. You'd say like var x equals 7, get element, you go window dot get element by ID p, like that. And then say dot text equals hello. And you could expect that doing that would find elements that are P elements and then change the text. This is probably not correct JavaScript. I'm making this up as I go. But you get the idea. Like, it's another kind of text file that has a different way of writing it, that has a different purpose. And its purpose is logic. Its purpose is to calculate things, do math, animate, do all the things that you relate to programming. And this was in Netscape 2, apparently, was the first instance of JavaScript. And that was in 1995. So 5 years later, we started having these. Now, over time, like browsers, they get different features. And as they get different features, they get capable of interpreting more and more different kinds of things. But at the end of the day, HTML, CSS, and JavaScript are the pieces of data that you receive as a browser that you interpret, right? The rest of the stuff is important, but it is much more secondary than these three things. Now, we're talking about the fact that in 1995, people were allowed to send code over your browser and run it. And to me, that's a massive red flag. And if it is to you, that's good, because it absolutely should be. Because the thing is that being able to put content on a screen isn't really a security risk, right? You can't really do anything like that. You might display horrible content to me, but you're not gonna. You can't really do more than that, right? You can send me swear words or something like that. Same with CSS, when you're able to change the colors of things, etc., etc. But when JavaScript was introduced, it brings up a really, really important point, and that's now over the web, people can send you code that runs without you having permission, like without you giving it permission to run. And if you don't consider the security of that situation, if you don't do something to stop people going rampant on your system, then you're going to get hacked right away. And so basically, from this point onwards, web browsers had to become what is called a sandbox environment. And what a sandbox environment means is that it's a place where code runs, right? So this baby here is the code. This baby is JavaScript. It's a place where code is allowed to run, but it's isolated from the surrounding system, okay? And this is a really important detail, because this is where a lot of hacks come from, and this is where a lot of like the anxiety about like browsers and hacks in general come from. If if JavaScript runs in a browser, it's essentially got all of these like barriers in the way of it interacting with things like your file system, interacting things like your hard drive. Because if it could interact with your hard drive, you could mistype a website name, go to a malicious website, and it could just delete your hard drive, right? So these are the kinds of things that you cannot have happen. If you've got any information on your computer, it could scroll through and it could try and steal your credit card information or your bank info or whatever, right? The point being that if the JavaScript running inside a browser was allowed to do whatever it wanted to do, then the system would not work because it would just be too easy to hack and manipulate and to abuse. And so basically, browsers are applications whose major concern is being able to run JavaScript and other kinds of code now, because there's been some changes since back then, and not have the person sending you that code be able to do anything malicious to you, right? And that's kind of it. So what I'm trying to tell you here is that a browser is just a sandbox environment for certain kinds of data, which you can create websites for you. And I know that was a bit long, but like this was an important one. What I'm going to do now is I'm going to jump over to the computer, and I'm actually going to show you how you can start to experiment with the fact that your browser is just this interpreting machine. Alrighty then, let's get into it. So first of all, you're going to start coding from now, and I want you to participate from now on. You're going to learn so much more if you actually try and play with the stuff I'm going to show you. So first of all, you need to download Visual Studio Code. This is just a text editor that is just really good. It makes it so much easier to code with. It's going to autocomplete half of the stuff for you. It's just get it. So once you get Visual Studio Code, right, we can do a thing with modern browsers, which is really useful. And that's what we can do is we can actually just write some HTML ourselves on our computer locally, and we can make the browser pretend that it's actually sending a message to a web server to get that HTML back, right? So what I'm going to do here is I'm going to make, just call this website, just call it malware. Just call it malware. You know, it's never anxiety invoking to have a folder called malware on your computer. And then you're going to open up the folder, right click. If you've asked for open with code, you're going to have this thing, but if not, go into your Visual Studio and then go file, open. Oh, that's nothing. You can see that. That's just it's helping someone out with something. Go here. We're going to go to malware like so. Good. So that's just the quick. I'm not going to show you how to do this. You can figure it out for yourselves, but get Visual Studio Code open it to that folder. The reason you open it to the folder is because now you can just start creating files on the side here. It's way easier. And we're going to start, and we're going to write an HTML file. I'm going to call this index.html. Index.html is the name simply because index.html is a convention, It doesn't have to be index.html, but it's easier if you make it so. And we're going to start with what I said. Now, this language is called HTML. Right? It's .html. The language is HTML. And like I said before, this language is completely about putting content on the screen. You're just ordering content. So it has these things called tags, and these tags allow you to sort of describe the content in your file. So there's a special one called head. Head is just where stuff that's not on the page goes. And then there's another one called body. And I'm not like a web guy, so I'm gonna forget things. But like I'm just kind of remembering. I think you can go title maybe. Yeah, there you go, title. And inside title you can say, you've been hacked. Right? And here you can go H1. H1 just means header. 1 is the biggest header, like 5 is the smallest header. And then what we're gonna say, haha, you've got some major problems, like this. And then P, which stands for paragraph, we're gonna put, you've been hacked. Email me 2 Bitcoin and I will free you from my wrath. Okay, so this is coming together. This is a pretty good malware website we're putting together here. But like I said, you can use a useful feature of a modern day browser to actually take a look at this as if it was an actual website. To do that, you're just going to go to your file system, and this should all work on Mac in relatively the same way, by the way. And when you see your index.html, you should have the logo of your browser next to it. You can come to properties and you can like change it to whatever browser you want, really. But if you double click it, it should open your browser for you. And then there we are. You have a website, right? So this website's boring, right? And this whole thing up here, right, is just because I'm grabbing it from my file system, and we're faking like doing a web request by just saying like go grab a file here, and like all these slashes are just like part of it, but don't worry about them. The point is that we've now received the browser. What it's done is it's taken this here, this path, it's asked that file to give its information, it's received that information back, and then it's interpreted it because it understands how to interpret HTML. Okay, so what if I hadn't given it HTML, right? That's oh my god, sorry. What if I hadn't given it HTML? Would it be able to do anything? Would it break to pieces? Let's just make a random file, and let's not make it a specific kind of file. We'll call this Faco malware. All right, Faco malware. And what are we going to put in here? We're just going to put some gibberish. Okay, here's some gibberish. Okay. If I go to my computer, like the logo isn't showing the browser, right? But that's just because the computer somewhere inside of it has a mapping that says if something ends in .html, then it's an HTML file. If I remove the .html from this, then it's not going to know that a browser can open it. But I could still go to properties. Oh no, I could still go to open with, wherever that is. Hello. Oh my god, okay, this is just a security feature. It doesn't want to tell you. I'll just give it a random extension with .a. It doesn't know what a .a file is, but I can tell it that .a files, I want it to open it with a browser. So let's go find a browser. Here's Firefox. We'll do Firefox this time. Okay, and let's try and open this with Firefox. It opens it with Firefox. Oh wow, would you look at that? It can still work. And that's because it doesn't need the .html, right? It doesn't need... It automatically knows from the syntax that it is .html. So what about this one, the Faco malware? Faco malware is not HTML. It's just random. It has no structure, right? Like this is clearly HTML. It tells you it's HTML right away, but this one, who knows what that is? Let's try and open it with the security feature that doesn't let me, doesn't have an extension, whatever, we'll do this. Okay, good. So it now knows that .a files are opened with Firefox. Click it. What happens? So it still displays it, right? But as you can see, it's just displayed the raw piece of information that I put in there, the raw data I would call it, but it's just letters. So the difference really between an HTML file and this rando file here is simply that. So if I do this, do that, let's do that again. Oh, that's because Visual Studio Code was kind enough to take away the extension for me. Just give me a sec. There we are. So what we're seeing here is that the only real difference between like random data being sent to, like being interpreted by a browser, and HTML being interpreted by a browser is that when it's HTML, the browser has some idea of what to do with it, right? Like how to display it in a certain way. It has some idea that it needs to display the title as a title and the password, or the paragraph, I mean, as like a smaller piece of text, right? So anyway, to return to what we had been originally talking about. So I mentioned that HTML is only for content, right? You can make another kind of file called a CSS file. So let's do what we were doing. We'll call this hacks.css, right? Because it's our hack theme. What are we going to need? We're going to need to say body, which just means this style I'm going to write is to do with the body. We're going to say background color. We're going to say red, okay? And then we're going to say P, and we're going to say color, I think. I don't know, color probably is, what's a horrible color? Let's say blue violet. All right, so if I run this now, as in if I go back to my malware folder here to test my beautiful piece of malware website, like so, I double click it, and what do I see? Nothing has changed. The reason for this is that the file that's being loaded is the HTML file, and the browser has no way of magically knowing that like it needs to load the CSS file as well. So what you can do in the HTML file here is you can actually tell it that you also want it to interpret a CSS file. And to do that, how do you do that again? Style, something like this, I think. href equals, oh my god, is that source equals /hacks .cs, something like this. Let's try this. This may or may not work. No, it wasn't that. Okay, so I'm gonna go figure that out, and then I'm gonna like zoom forward the video. Okay, so I have on the side figured out how to actually do this. Apparently you got to do this. You've got to put link, rel, style sheet, type, text, href, my style. We're going to go .hacks.cs, hacks.css, like so. Media screen, apparently. I don't know what that's all about. It'll probably work though. Let's give that a try, shall we? Awesome. That's more like it. Okay, I'm going to show you that. That's so much better. I'm so happy about this. Okay, so good. So we've got our beautiful whatever it was, Alice blue, or like strawberry, like blueberry blue writing. We got our beautiful red background. Where we're gonna scare some people with this malware. So if we go back here, we can maybe do some more stuff. I can say, all right, let's also do like text aligned center. Let's do H1. We need that. Text align center 2. Text align center. Let's maybe do, I know if you do body, I think padding. I think you can go like padding top even. Top padding. I know that's gonna do something. So let's just put some 50 pixels in there, etc., etc. Now if I take this and I refresh it, now we got our, haha, you've got some major problems over here, and you've got that down there. So basically what I'm trying to say here is that there's two layers to this now. There's the initial layer, which is the content, which really just tells you what order content goes in. And then there's the second layer, which is the CSS, which is showing the, telling it how to style it. But the thing is, there is a final part to this puzzle, and that is the JavaScript. Hacks.javascript, right? And at the end of the day, JavaScript is a programming language. So there's like many different things that we can do with it. I think what we're going to do is we're going to make this on an interval keep giving you an alert. Let's try that, shall we? So I know that JavaScript, you can say set interval, and you can pass what's called a function. which I'll come up with in a second, and then you can tell it how many milliseconds you want it to take to do. So let's say every half second. Okay, we're going to create a function. We're going to call function hack alert, like so. And in this function, I'm just going to say alert. I think I can do that. Or window, maybe. Window.alert. No. Maybe. Let's try that. Window.alert. And we're just going to say you're hacked. Okay, good. Do something like that. Throw hack alert in there. Like so. And then if I run this, I have to link it again, right? And so I'm pretty sure I have to go like script source equals ./index.html. I think that's how you do it. Again, I'm really not that, I don't make that many websites. And so if I go back to here and I run this, is that gonna do anything? No, it's not. So let me double check the internet again. All right, so I figured out why my thing isn't working. It's because I didn't even type the right thing. So let's just do this quickly. Now we've got some JS running in there. All right, so if I bring back our beautiful website and I oh no, you're hacked. Oh no, look at that. We've just created a fantastic malware website that is blocking me from getting away from this alert, and it's just telling me I'm hacked. So a part of the reason I'm showing this is to teach you about like the various components, obviously, of a website, but also I'm trying to show you that like people can make it, like that didn't take very long for me to like make things pop up on the screen and make the websites feel really scary, even though the website's not really able to do anything at all, right? Like it's just showing a pop-up and it's making it annoying, but like it didn't steal any of my information because the browser is a sandbox. So I'm going to stop there. This is the first code, which is good. Next time we're going to go into website servers and start talking about how you could potentially make your own website.